Hello, students. Good morning, good afternoon, good evening, good night. I don't know when you are watching my video, so you consider it as per your own convenience, own time, right? So, in this lecture, I am going to explain about how to find out equivalent resistance of a electrical network. As you are engineering student, you should know how to find out equivalent resistance of series connection, of parallel connection, or combination of series and parallel connections. So already a class 12 में भी था. Everybody know that how to find out equivalent resistance, but here I'll give some shortcut. That shortcut you can implement or you can apply in the electrical network. You can get the answer as quick as possible. So without wasting our time, we'll start the video. My name is S.R. Christy and you are watching my beautiful channel Love You Science. So let's get started. Okay, before going to the trick, let me share some basic information about series and parallel combination. If you do not know what are the series connection, what are the parallel connections, so here is the solution. So in series connection में क्या होता है? There are resistance connected in this manner, like here current will be same and the voltage drop will be different. That you should remember. The potential drop across two resistance will be different. That depends on the magnitude of resistance and current is same. Since there is no junction over here. But in parallel connection, so resistance are connected in this way. This is R1 and R2. So in parallel connection, the voltage which is given or the potential drop across the resistance will be same and current will be different. So current is I1, I2 will be different. That value depends on the value of resistance, but potential difference or voltage will be same. So that part, that thing at least you should know. Okay, then we'll go to the trick. So since our topic is to find out equivalent resistance, in series connection equivalent resistance is just R1 plus R2. If there are three resistance, R1 plus R2 plus R3. But in parallel connection, what is the traditional formula? Method 1 by R is equal to 1 by R1 plus 1 by R2. So by using that formula, we can find out the equivalent resistance. Instead of using that formula, what I'm going to say, better you apply this trick. Equivalent resistance is bigger one by ratio plus one. Here ratio is big by small. So let there are two resistance are in parallel. One is big and other is small. So directly you can find out the equivalent resistance will be bigger one by ratio. Ratio matlab big by small is the ratio plus one. So you can get the answer. Okay, let's take example of parallel circuit. Let there are two resistance, like one is 6 ohm, other is 3 ohm, are connected in parallel. What is the equivalent resistance? So if I go for the traditional method, 1 by R will be equal to 1 by R1 plus 1 by R2. So here it is 1 by 6 plus 1 by 3 and LCM is 6, so it will be 1 plus 2, that is coming 3 by 6, which is coming 1 by 2. So 1 by R is coming 1 by 2, matlab R is coming 2. So see the shortcut, by using that shortcut you can able to get the answer within 3 seconds, right? What is the big one here? Big one is 6. What is the ratio? 6 upon 3 is 2. 2 plus 1 is 3. So answer is 2. Here also we got answer 2. So no doubt this formula is universally accepted. It is true, but in some cases, what happen? It unnecessary will be wasting your time. So instead of going for that, better you go for this shortcut, especially in engineering solution, right? So let us take another example. Let we have a resistance of 81 ohm and another is 27 ohm. So we can use this formula. It will take more time. So by using that shortcut, we can able to answer this within 2 seconds. See, out of the two, which is big one is 81. So what is the ratio? 81 upon 27 is 3. 3 plus 1 is 4. So answer is 81 upon 4. And remember one thing, you'll be implement that formula when that resistance value is given in terms of ratio. So it will save your time, right? So let us take example. Let we have 4 ohm resistor and 4 ohm resistor. What is the answer to? See, I can get this answer by using the shortcut. What is the big one? Big one is here 4. Anyone is big one 4. What is the ratio? 1. 4 by 4 is 1. 1 plus 1 is 2. So answer is 2. Or else you can go for the traditional method. 1 by r is equal to 1 by r1 plus 1 by r2. So it is 1 by 4 plus 1 by 4. It is 2 by 4. So r is coming 4 by 2. Answer is 2. Right. So what you conclude from here, if two equal resistors are connected in parallel, answer is half of that. Let us take one more example. Like let we have a circuit connected like this. Okay, we'll find out the equivalent resistance between A and B. Let it be 6 ohm, 3 ohm, it is 2 ohm, it is 4 ohm. So within 3 seconds you can get the answer. 6 and 3 both are in parallel. मैंने शॉर्टकट क्या बोला था? Big one by ratio plus one. What is big? 6. What is ratio? 2. 2 plus 1 is 3. So 6 by 3 is 2. So the entire answer is coming 2. So I can replace this part. I can take 2 ohm resistor here. So now this 2 ohm and 2 ohm both are in series. In case of series, resistance will be additive. 2 and 2, it will be 4. So it is coming 4. So now 4 ohm, 4 ohm both are in parallel. So what is the answer? मैंने क्या बोला था? If two equal resistance are connected in parallel, answer will be half of that. कितना हो जाएगा? 2. So equivalent resistance will be 2. Okay, I am giving one question to you. You solve it. You pause it. Pause the video and solve. Then you tell me the answer. वीडियो को एक बार पॉज करके सॉल्व करो. डन. Okay, देखो 12 and 12 both are in parallel. So what is the answer? 6. So I can write here 6. Now 6 and 3 both are in parallel. So big one by ratio plus 1. 6 by ratio kitna hai? 2. 2 plus 1 is 3. 6 by 3 is 2. So I can replace this one as 2 ohm. Now the point is how to find out equivalent resistance here. So here 7 ohm resistor is there. Nothing is there. Matlab it is a short circuit. So resistance will be 0. So any zero resistance, any resistance having zero magnitude, if it is connected parallel to other resistance, the equivalent resistance will be 0. Or else you can say if any resistance is connected to zero resistance, the total answer will be 0. So matlab it has no meaning. So ये zero resistance matlab short path. So now 2 ohm and 2 ohm both are in parallel. So equal resistance, so answer is half of that. Half of any values. 2 by 2 is 1. So answer is 1. So here we'll go to the next question. So we have a circuit having three resistors 20, 30 and 20 are connected in this fashion, and a potential difference of 12 volt is given to that circuit. We'll find out the current. We'll find out the supply current. So before finding the supply current, we have to find out the net resistance of the circuit. So clearly you can see the 30 and 20 ohm resistor both are in series, because here current is not dividing, current is same. So I can replace this entire part to a 50 ohm resistor, because both are in series. The answer is 50 ohm. So across these two terminal I can keep one resistance, that is 50 ohm. 20 plus 30. Then so clearly you can say this 20 ohm and 50 ohm both are in parallel. So to find out the equivalent resistance, you have various options. You have the traditional formula like 1 by r is equal to 1 by r1 plus 1 by r2. So you can use that one. But since I have given the shortcut, better you go for this method. The big one by ratio plus 1. What is big one? 50. What is the ratio? 2.5 plus 1 is 3.5. So it is coming 50 upon 3.5 or 100 upon 7. So the equivalent resistance is coming 100 upon 7. So potential difference is given 12 volts. So what is the current? As per the Ohm's law, voltage upon resistance. Voltage is 12, resistance is 100 upon 7. So it is coming 84 upon 100, which is 0.84. So that is your answer. So look at the question. Next question we have. There is a circuit is given here. 24 volt of potential difference is given across A and B. We have to find out what is the supply current. So before going to that, we'll find out the equivalent resistance across A and B. So here the 9 ohm and 3 ohm both are in series, and 2 and 6 both are in series. So what I can write, this point is A and this point is B. Our potential difference is 20 volt. So across A and B there is a resistance of 12 ohm. Okay, since both are in series, 9 plus 3 is 12 ohm. So again to the left side, 6 and 2 both are in series, 6 and 2 is 8 ohm. So now this 8 ohm and 12 ohm both are in parallel. So I can redraw the circuit as like here 24 volt. This point is AB, just to make you understand. So I can redraw the circuit as like it is 12 ohm and this one is 8 ohm. There is no difference, right? So now tell me what is the equivalent resistance. So clearly you can see, or you can say both are in parallel. So what is the equivalent resistance? The equivalent resistance is big 1 by ratio plus 1. So in this case better you apply 1 by R is equal to 1 by R1 plus 1 by R2. Okay, so it is the LCM is, let it be 48, 48 6 plus 4 to 10 upon 48. So R is coming 48 upon 10. So it is coming 24 upon 5. Right. So as per the Ohm's law, current is voltage upon resistance. So voltage is 24, resistance is 24 upon 5. So your current is 5 ampere. So that is your answer. So here we have another question. We'll find out the equivalent resistance between A and B. So 2 ohm and 4 ohm both are in series. So we are taking from right hand side. So 2 and 4 is 6. So I can replace that one as 6. Just a minute. It is coming 6 ohm. So now the 6 ohm and 6 ohm both are in parallel. So if it is parallel, so what is the answer? 3. I have told you two equal resistance are connected in parallel. Answer is half of that. So I can replace this entire part and keep a 3 ohm resistor. Keep a 3 ohm resistor. So now this 5 and 3 both are in series. If both are in series, what will be your answer? 8. So I can replace this part as 8 ohm resistors. So now 8 and 8, 8 and 8 both are in parallel. So what is the answer? Half of that, just 8 by 2 matlab 4. So I can give a 4 ohm resistor here. Okay. Now 3 and 4 both are in series. So what is your answer? 3 plus 4 is 7. So in this question we'll find out what is the supply current, what is the current flowing from the source. So in the circuit there are various resistance are connected in a different way. So we have to find out what is the supply current across what is the supply current. So before that we'll find out the equivalent resistance across the 2 point of the supply. Let there are 2 point A and B. So across A and B we'll find out the equivalent resistance. Then we can apply Ohm's law, that is current is equal to voltage upon resistance. Okay. So how to find out the equivalent resistance here? It's very simple. 5 ohm and 4 ohm both are in series. So if both are in series, so what is your answer? 5 plus 9 is 14. So I can replace this one as a 14 ohm resistor, right? So now looking or about these 2 point, what is the equivalent resistance? Both are in parallel. So what is the equivalent resistance? 7 ohm. As I have told, two equal resistance, if they are connected in parallel, answer is half of that. So I can replace this entire part to a single resistance of 7 ohm. So now we can clearly say the 11 and 7 both are in series because there is no junction, current is same. So your answer will be 11 plus 7, that is 18. So I can replace this entire part and keep one resistance of 18 ohm magnitude. So now about these 2 points, there are two resistors are in parallel and both are having equal value. So what is the equivalent resistance? Half of that, half of any value, that is 9. 18 and 18 both are in parallel. What is the answer? 18. 9. Sorry, 9. So now it is 9 ohm. So 9 ohm and 13 ohm both are in series. And what is the answer? It will be 13 plus 9 is 22. So I can replace this entire part and keep a resistance of magnitude 22 ohm. So now 22 and 22 both are in parallel. What is the answer? 11 ohm. So I can replace this part and keep a 11 ohm resistor here. Okay. So we'll have to find out the equivalent resistance across A and B. So looking from the two terminal of the supply, that is A and B, we can say like 11 and 1 both are in series because there is no junction. So if it is series, so what is the equivalent resistance? 11 plus 1, that is 12 ohm. Supply voltage is given 24 volt. What is current? Voltage upon resistance. 24 upon 12. It is 2 ampere. Okay. Okay, see, this is a very interesting question. That question I got from Wikimedia book that I'm going to explain. It's very easy question. Um okay, coming to the next question. So here, the question is, what is the value of R? What is the value of R if this current through the X ohm resistor is 0. Current through this resistor, if it is 0, what is the value of R? That is your first bit. And second bit, at the same time, in the same logic, or in the same condition, we have to find out what is this supply current. It's a very interesting question. Most of this type of question may come in exam. Uh, Again, I repeat, what is the value of the resistance if current through this resistance is 0? Okay, so let us solve. See, I can rearrange the circuit in this way. Let this term point is O and this point is already A. I have mentioned A, B, C. So let this point is A. Okay, and this point is C. So across AC, so coming to the next questions, this question is given, if current through this branch is 0, what is the value of R? Try to understand the question. Very interesting question. If current through this branch, if it is 0, what is the value of R? And in the same condition, what is the value of supply current? So that means we have to find out the value of R and the value of supply current. And one condition is given. The current through this branch is 0. So look at the question carefully. It is a balanced Wheaton bridge circuit. Only this portion. How? I'll explain. Let us focus on these 2 points B. So here, some part of the circuit is balanced Wheaton bridge. So here, some part of the circuit that follows balanced Wheaton bridge condition. So that means we can say this portion is a balanced Wheaton bridge circuit. So you have already read in class 12th the condition of balanced Wheaton bridge क्या है? The ratio of adjacent resistance will be same. Or if galvanometer shows the zero deflection or zero reading, then you can say that circuit is under balance condition. So here, so let us consider these 2 points B and C and A and O. A and O. So in between B and A there is a resistance, and in between A and C there is one more resistance of 1.5 ohm. Between B to O there is a resistance of 4 ohm, and from O to C there is another resistance of R ohm, and from A to O there is a resistance of X ohm, right? So in between B and C there is a power supply of potential difference 10 volt with a resistance of 2 ohm in series with it. So there is no difference between these two circuits. What I did, I just redraw the circuit. I just rearrange the circuit to make you understand. So clearly you can see if current through this branch, if it is 0, so this portion you can say it is a balanced Wheaton bridge kind of circuit. So if current through this branch is 0, so that means I can say the ratio of adjacent resistance will be equal. So matlab 1 by 4 will be equal to 1.5 upon R. So what is the value of R? R is 6 ohm. So R is 6 ohm. Then, so now we'll find out the equivalent total resistance, total equivalent resistance across these 2 points. Let this point, one point is B, let this point is D. So across this point B, and D will find out the equivalent resistance. Uh, so that we can easily find out the current, because it is asking to find out the current. So now 1 and 1.5 ohm both are in series, because which में जो resistance है ना X, it was since current is 0, so it has no meaning. So I have omitted this one. So 1 and 1.5 will be 2.5 ohm. 4 and R is given how much? 6 ohm. So 4 and 6, it is 10. So now 10 and 2 both are in parallel. This entire part is 2.5 and this entire part is 10. So 10 and 2.5 both are in parallel. What is the equivalent resistance? मैंने क्या बोला था? Big by ratio plus 1. What is bigger one? इसमें bigger one is 10. What is the ratio? 10 by 2.5 is 4. 4 plus 1 is 5. So 10 by 5 is 2. So that means I can replace this entire part to a single resistance of magnitude 2 ohm. Of resistance 2 ohm. So now this 2 ohm and 2 ohm both are in series, since there is no junction over here. So equivalent resistance is 4 ohm. And your supply voltage is given, sorry, 10 volt. It is given 10 volt. Supply voltage is given 10 volt. What is the current? As per the Ohm's law, V by R equivalent. So 10 by 4 is 2.5. So your final answer is current 2.5 ampere. 2.5 ampere. Okay. I hope you understood this concept. Okay. So with this, I am ending this lecture. Hope you understood what I have taught in this class. So thank you so much for watching my video. If you like my video, please do subscribe it. Thank you. Thank you so much. With this, I am ending this lecture. I hope you understood what I have explained to you. So thank you so much for watching my video. If you like my video, please do subscribe and share. Thank you. Thank you so much.